Talk to you briefly about a statement or a proposition and its contrapositive. Now, a statement and its contrapositive are said to be logically equivalent. That means they're either both true together or they're both false together. And often you're better off trying to prove the contrapositive. It seems like it may be sometimes a little more direct to do it that way, or the other way around. Now, I'm not going to get into the nature of the proof of this. I'm just going to go with this as a statement that's known to be true. This states that if K is not a power of 2, and this, y'all, this means for all. This is what they call a universal quantifier. This upside down A means for all non-negative positive, all non-negative integers. If you have this condition on the left-hand side, then it's going to be the case that 2 raised to the K plus 1 is always composite. Now, what do we mean by composite? It just means not a prime. For example, 15 is a composite number. It has 4 divisors, 1 and 15 and 3 and 5, so it's composite. All right. Now, we can, if you want to think of this as just a proposition, you can call this left-hand side A. All right. And I'll just make a single error here. So this would read A. The truth of A implies the truth of B. Okay. Now the form of the composition is the negation of this in reverse. And what I mean by that is these symbols here, the tilde is often used as a prefix, I think, or a whatever they call it, logical operator to negate. All right, so you have not B, okay, is this statement, because here they're telling you that 2 to the K plus 1 is prime. Here we said 2 to the K plus 1 was composite, right? So this statement right here goes in front, and it's the negation of this statement right here. Okay, now let's go ahead and draw this arrow right here. Now the right-hand side's a little trickier, but the negation of a for all is there exists. Okay, and if you just think about this, it makes quite a bit of sense. You know, that this not B implies not A. Okay, so this part right here would be not A, right? Now, one way to think of it, quote, a common sense level is like this. Let's say A means it is raining. Okay, well, then B could mean the ground is wet, right? But not B would say if the ground is not wet, it's not raining, right? So you see, it makes sense. It makes sense, and it works in mathematics too. Now, I would like to close by giving you just a concrete example right here. So 2 to the K, let's try out 2 to the 8th plus 1. Okay, 2 to the 8th plus 1. That's supposed to be an 8, folks, sorry. Let me make that neater. 2 to the 8th plus 1. Okay, that, y'all, that is 256. That's equal to 257. Okay, now it turns out this is prime. It doesn't have to be prime, but if it does happen to be prime, then it's going to meet the condition of this contrapositive. Okay, so 257. It's not too hard to show that's prime. All you have to do is consider the square root of 257, which is about 16, and check all the prime divisors to see if they divide 257. So 2, 3, 5, 7, 11, and 13 are all less than the square root of 257, right? So this is indeed prime, just like this says. But notice the K over here would correspond to 8. 8 is equal to 8 is equal to 2 raised to the 3rd power. Okay, so you see that would be this N that you see right here. And this right here means there exists, folks. This symbol right here is an existential quantifier. It says there exists an N. Okay, so y'all, sometimes one is easier to prove than the other. I proved this one in an earlier video. I thought it was easier to prove this, but this could all be reversed too. This could be A implies B down here, you could call this A implies B, and then not B implies not A up there. So anyway, just a little note that contrapositives are actually quite useful when figuring out a way to prove things. And also many textbook authors will state a proof, will write down a theorem and actually prove the contrapositive without even telling you, which seems kind of confusing sometimes. So anyway, I hope that helped.